Hi guys, welcome back to the channel. So now we are going to be solving weekly contest third question, which is shortest uncommon substring in an array. We are given an array of size n, and then it is consisting of non-empty strings, and then we are also given an we should find the answer of size n such that answer of I is the shortest substring of array I that doesn't occur as a substring in any other string in the array. And then if there are multiple substrings exist, then we need to return the answer I that should be lexicographically smallest. That means it should be alphabetically smallest. And then we need to return this particular answer. So let's take this particular example. Let's say we are given this particular array which consists of all the substrings which are present. Now we'll try to, let's say we have C cap. This is the string we have. Now we need to find the answer for this particular index, which is, suppose let's say we have C. We have C and then we have A and then we have B. Out of all these substring, whether this particular substring exists in other substrings or not. Suppose let's say C. C is present here as a substring of this particular string. So this cannot be taken. So this C cannot be taken. So let's come to this particular A. Whether A is present in other strings as a substring. Yes, it is present here and then it is present here. So we'll not be taking A as answer. So let's take B. So for this particular B, whether this particular B exists in other strings or not. Yes, it exists here. So we cannot return this B. We cannot take this as answer. So let's consider another substring which is CA. So CA is present or not? Let's see. CA, CA, CA. So CA is not present. So this can be the answer, but this is not the final answer. Why? Because there is one more substring which is AB, which is lexicographically smaller than CA. That means this is alphabetically smaller than CA. So we will see whether this AB is present as a substring. AB is present. No, AB is not present as a substring. So we are going to say this will be the answer for this particular index. So see, this will be the answer for this particular index. And then let's come to another index which is AD. For this we are going to check the substrings which starts with the length of 1. So we are going to say 1 which is A. A is present here, so A will not be taken as answer. D is present here, so it will not be taken into the answer. AD is present in this particular string, so we are not going, we'll say the answer doesn't exist, so we'll take it as empty. For this, B is present here, and then A is present here, and then D is present here. So it cannot be length of 1. Let's consider with BA. BA is present or not? BA is not present. So this can be the answer. There is also one more string. Let's see that. AD is also present. So AD exists in another string. So we are going to say BA is the answer. So we'll we'll take it as BA. And then we'll come to C. C is already present. So this will not be taken as answer. So that's what we are going to do. So for this particular question, so how can we solve? Let's say for each particular index, let's say for each index, we will store all the substrings which are present and check whether it is present in other strings or not. So we are going to do this. Suppose let's say we have this particular index. For each substring which is present in this string, we are going to check each string whether this particular substring exists or not. But as we check for all the strings and then we are going to check again all the substrings, instead of doing that, let's store in the map so that we'll say whether this particular string exists or not. Suppose let's say CA doesn't exist. So how can we do that? We can say we can store all the substrings which are present and then we'll try to increment the frequency. Suppose let's take MP of CA equal to 1. This will be assigned at this particular case and then again we'll see whether this CA is present or not. No, it's not present. So every time we see the index, we are doing the substrings frequency greater. We'll be incrementing to 1 and then we'll check for the other substrings, and then after this operation to check whether this particular CA is exist in this string or others, we'll remove all the substrings which are present in this particular index and then we'll check whether the map is equal to 0. If it is 0, then we are going to say that particular substring doesn't exist in another string. So we'll store the answer and then we'll try to return the answer. So let's see the solution for this. So this particular string will take two strings and then it will return the lexicographically smallest. That means the smallest alphabetical string. So if a dot size is less, then we are going to say B will be returned, and then a dot size is less, then we are going to say A is answer, and then B dot size is less, and then we are going to say B is the answer. Suppose let's say at particular character we say A of I is less than B of I, then we are going to say this is the answer, and then for other case this will be the answer. So for other case it will be A. And then this will store the strings whether this particular substring is exist or not. Instead of taking boolean value, we'll take the integer value so that we'll get the count of all the substrings which are present in this particular array of strings. So whenever we want to decrement this particular string which is at particular index, we can decrement that and then we can check for other arrays whether it is existed or not. So we'll go through all the elements which are present in the array, and then for each array we are going to take this k as size, and then for each size we are going to choose the starting index which can be 0 to j plus k minus 1, so that this will not be greater than array of I dot size. So we are putting this condition, and then every time we get some particular substring, we'll try to increment the frequency for that. So we are doing the same thing. So let's go through all the elements which are present again, and then we'll remove the frequency of all the substrings which are present in the current string, so that we'll check only the frequency of other elements present in the array, and then if the substring is existed in that array, we'll try to use that as an answer. So we are decrementing here, and then we'll check whether the smallest substrings is not present in the whole other substrings in the array. So we'll pick all the substrings which are present in this particular current string, and we'll check whether this is not present in other strings in the array. If it is not present, then we are going to say this will be the answer when this becomes minimum substring. So we'll do we had checked previously, that is the exact function we are writing. Suppose let's say the answer exists, then we don't need to check for other sizes, which will be k plus 1. So we'll come out of the loop, and then again we need to add all the substrings which are present in the current string. Why? Because we have this particular string, and then whenever we move from here to here, we will add all the substrings which are present here, so that whenever we want to check the substring which is present in this current string, so this will be counted, and then whenever we move here, we will remove all the substrings present in this particular string. So for this particular string, we are incrementing all the substrings which are present, and then at last we are going to say this will be the answer. Yeah, if we come to the time and space complexity, as we are taking the total array, this will be big O of n, and then again we are checking for each substring, which will be array of size. So n, this will be the n, and then this will be the average length of this array, and then for this particular string, this is going to be big O of array length. So this is going to be n length square. That will be the time complexity, and then space complexity is going to be big O of number of substrings we can make out of this. So that will be 20 into 19. So those are the different number of substrings we can make. Yeah, that's all for this video. Thanks for watching.